Hello YouTube viewers, welcome to my channel Science or Technology. In today's show, Future Friday, we're going to talk about future of aviation. So let's dive right into it. Now, aviation is one of those odd industry that is growing exponentially and it has enough room to grow. For example, vehicle industries is not growing simply because every person who can afford a car already has a car, and the number of new car buyers that are like, I never had a car, now I'm buying my first car, that number is not growing, actually shrinking. And not to mention human population is also shrinking. So that industry is reaching a point where it has crossed the apex. Of course, it's switching from internal combustion to electric for some reason, but okay, that's happening. So it's not growing exponentially. Very few industries right now, practically speaking, is growing exponentially. Even iPhones, they were growing exponentially and then they reached plateau. So this industry, on the other hand, is growing exponentially simply because it has enough unused capacity that is like, we can use it more. And more people will use flight simply because as more and more living standards goes up, even in India, even in Africa, more and more people will use it. India simply crossed 5% of population utilization of aircrafts, meaning 5% of Indian people, if you just randomly talk to them, it's like, have you ever been a flight? They will say yes. Now that number may sound very bad, it's like 5%, but here's the deal. Put India's population into the mix. That number is huge. That is like many European countries have smaller grand total population with that 5%. That's the whole context. Like most time people don't understand how big India and China is. Like we are on a whole different level. Like as in like USA is apparently around third largest country. You have to remove 1 billion people from India. Remainder will make the third largest country. So 5% may sound bad, but anybody who has traveled in India airports is like, dude, why it's so crowded? 5%. That's the whole point. Now, this puppy consumes fuel like there is no tomorrow. It's like fuel, oh, that's my drink, my bread and butter. Everything is fuel. You just consume fuel like there is no tomorrow. And they consume JP1, which is a kerosene variant. Basically, you take kerosene, you purify the hell out of it. You add some additives that allows like some functions for jet engines. Manufacturers will tell you what to add. And then you take this puppy, refine it even more. That makes you RP1, that is rocket fuel. So it consumes boatload of it, like insane amount of consumption is there. Consequence, the carbon footprint is growing. Like Indian government have realized this very well on that this is a new small airport that was opened recently, and there are many other small airports that are being added to the map recently. Now they do not make money right now, of course they don't, but this is one of those sort of system where it's like a seed. They are planting a seed that over the coming decades it will grow into a plant. It will allow the economy to grow, it will allow people to have higher mobility, it will allow, like for example, this location is very well connected to Calcutta, Delhi. Like Calcutta, it's close enough to from train that people will use train, but Delhi is like train is like around 18 hours, flight is 2.5 hours. Bangalore, that is almost like 36 hours. Again, train line is not direct, so it does take long. Flight, again, 2.5 hours. So doing this sort of interconnect, not just like every airport does not need to be international, but having this sort of regional good connection, that's really good. And India does have its own carrier. For example, Indigo started from like a small carrier provider to like the amount of jets this puppy have is huge. So aviation is growing and is growing exponentially. Even after pandemic, it recovered back surprisingly quickly. So what is the first change that we most likely to see? First change is Wheeltug. Now you have to understand these engines, they are lovely piece of engineering. They love air and they consume a lot of fuel and they do it very efficiently, because if you compare the speed, the range, basically if you take Airbus A380 engines and it's like how many people it's moving, how much distance it can carry on full tank of fuel, it's surprisingly efficient. Like there is nothing on this planet that can even carry you even in slow speed to that kind of like distance. Flat out, these puppies are efficient. Consequence, they love high altitude air, meaning they are designed for that. They are like, if you are above 8 kilometers and around below 15 kilometers, they are like, that's my sweet spot, that's my G spot. They work awesome. Land is one of those places they do not work. Flat out, the moment a plane engine lands, it goes into dirty air scenario, meaning whenever you talk about people whose job is to maintain these engines, the majority of damage is not incurred when you are like flying cross continent, things of that nature. Majority of the damage happens in taxiing. It's like, how? The reality is it's because so close to the ground, and these fans, they suck air like there is no other. They are like open-ended vacuum cleaners, so they can suck a lot of dust, dirt, debris, and that does cause damage. So is very wasteful. Like on land, not only it's very inefficient in terms of fuel, it's very basically noisy also. Airport noise primarily comes from taxiing, and it's also wasteful. Again, companies care about profit, profit cares about efficiency. Efficiency is wasted when you are running these sort of big boys in low to the ground state. They do not like that. And it's also harmful for the ground crew, because again even this small one that can suck people in. If you have a giant one like Airbus A380 kind of engines, that will suck people from far away. It's like, hey, poof. So you have to understand these are very serious things, and ground crew have to be trained, and it does add time. It does add time, like how quickly a plane can be docked to the gates versus if it has big engines, it does take time to spool down to become safe and all that jazz. And engine, again, even engine is not happy with that. It's like, I also don't want to run this close to a soil ion. It's like engines are designed for like free clean air. So somebody come up with the idea. It's like, hey, we already have APU which are designed for this sort of environment where it's like, of course, it can run, low to the ground and still work properly. It still works in that efficiency band and does not have too much noise pollution. And so why don't we use the power that is generated by APU to drive motor in the landing gear? Now you may be like, okay, does not sound odd. Like, we had motor for almost a century. Then why didn't we do this? Well, reality was like, if you back in the days, people sat down, figured out how much space and like in terms of mass they had, like around how much weight they can carry. That was like around 200 kilograms. Basically, anything they wanted to add in a jumbo jet, two-seater engine jumbo jet, they had 200 kilograms of capacity, and everything should be inside it. Meaning the motor, the battery, the wiring, everything should fit inside that 200 kilogram envelope. And back in the day, there was no technology, because EV technology, whether you like it or not like it, they did create ludicrously high power density motors. Meaning right now you can just go to the companies and buy a motor that is like this size and 500 horsepower. Let that sink in. Something that I can physically carry is 500 horsepower. That's possible. So that development of motor technology in the background, the development of motor drivers in the background, that opened up the avenue where it's like somebody thought, it's like, hey, I think we can fit inside that weight envelope. So what will you gain if you do this? Like, that's why this company is showing it. It's like they cover the engine cowling completely to make sure, no doubt, there is like it's directly running on. It's a hub wheel system. This is attach on system. There are many companies that are working on this simultaneously. So be mindful. It's not necessary that you will see the Wheeltug only becoming the future. It does have the hub motor. The benefit of that is it's super easy to add on. This does require a bit more involved. It does have a gearing system. So, but again, both of them inherently do the same thing. This is a bit more cleaner install, and more likely for the last 2 years they are slowly trying to attract partners. So APU will drive the electric bus. Electric bus will drive the basically hub motors, and that will drive the nose gear generally. Now, what will it save? Like, doing this sort of thing, what will you gain from it? Well, first, fuel. The rising fuel cost was another reason, because if fuel was cheap enough, why the hell bother developing and researching and certifying? Certifying in aviation is a ludicrously difficult thing. Meaning, this puppy you can find 10 years ago, as in like videos, same company doing 10 years ago. It took that long to certify. So this is one of those things where, that's why whenever you see in any YouTube, it's like new jet design, it's never gonna happen. Certification process is so goddamn long, no company is gonna like, yeah, I'm gonna keep burning billions of dollars to get it certified. So, and the fuel price was another aspect. Back in the days, fuel was cheap enough. Now it's expensive, so saving even few liters is like, you know what, it's worth that 200 kilogram penalty. Time. Now, time is another multiplying factor. For example, if Indigo gets hold of this, they may literally increase one flight extra per day, simply because that's much time you can save from this. It's a very big thing. And not to mention, your engine on time will also go down. That is exponentially profitable to you. And noise saved, because you are no longer creating noise of like, taxing engines. You are just APUs. So this is a very desirable technology that is slowly working, and I hope to see before I'm dead this becoming a reality, a Wheeltug system. And it has a very big impact. Like, you may think it's a tiny thing. No, it's a very big impact, especially on crowded airports. Like, very, very big impact. They talk about like saving around 8 to 20 minutes per flight. That's a lot. So we come to another aspect, electrical. Now, electrical is one of those things that's always happening in the background. You never think about it, but it's also going through some development. For example, the primary change that has already happened, and majority of the new jets that are being delivered, it has solid state electrical subsystem, meaning every safety circuit used to be like old mechanical style, like they were like circuit breakers. But nowadays, even that is becoming solid state. Benefit of that, it's far more reliable, far more effective, and it does have better health monitoring system, where it itself can tell you, it's like, bro, you should service me. So it is creating aircraft that is far more stable, far more electrically reliable, resilient, and General Electric is working on it. I have provided the video down below, and it's a good thing. That's a very minor improvement, but improvement nonetheless. Now, that's just a good backbone structure. Then we come to the granddaddy. The hope that every company right now is working on is that electrical starter generator unit. Our cars also already went through this change, and if you are in India, there is a good chance you have already have scooties that already have this technology. Back in the days, we had scooty that had a starter motor and had a alternator kind of circuitry. Somebody figured out, just throw both of them away, put one thing there. It's like motor and generator are inherently the same thing. Once you feed electricity, once you extract electricity, that's it. Mechanically it's the same thing. So it's just a BLDC motor that you can right now buy, as in like it's a two-wheeler, very popular in India. And then if you are dealing with basically vehicles, cars, 4-engine systems, if especially you are dealing with luxury cars, they already have it. Somebody figured out, it's like, hey, why I have alternator, why I have starter, throw both of them away, put one big motor there that will act as a generator in normal running and act as a like a starter at the start. So that's the future. It's happening with everything. So why does it will happen to jet engine also? Problem with that, right now jet engines, especially big bypass fan, they consume way too much power. The only way to power that kind of oomph, that kind of mass with enough RPM is compressed air. Basically APUs is the only thing that we can start with battery. Battery starts the APU gets through the full RPM, it triggers a compressor feeds the power to basically bypass ducts, basically that feeds the power through bypass line, and then that spins a basically a small turbine in invert. Basically you are feeding compressed air, is spinning into turbine, it creates enough horsepower that it starts to spin the main thing, and then over time it builds up the RPM, and then around 40% of the total RPM it starts to ignite the fuel. It does work, awesome system. Problem, it's an extra hassle that you are adding, and you still need electrical generator on this. So why don't you throw the air part away and just make the electrical generator into an electrical starter also, and more powerful unit? Because again, even commercial aircraft, they want to add more instrumentation, they want to add more infotainment system, they want to add more satellite communication system, more powerful weather radar system, long range communication systems. Those will consume power. And fighter jet, again, they flat out every fighter jet 6th generation that everybody is working on right now, like Rolls-Royce, they're flat out. It's like, we're gonna need boatload of power in future, boatload of power. Like the jet power is just one thing, electrical power would go exponentially higher. So how do we achieve that? Like that's, okay, it's a good thing. Then how do we achieve it? Well, we have to make super high density motors, meaning this puppy. This puppy is a tiny thing. Again, you can say this, like this is an APU kind of motor, or Rolls-Royce is working on the next generation of engines that will be used in 6th generation fighter. Like this is a test bed technology as of now. And this puppy is around under 60 liters, and this has 2.5 megawatts of power. Let that sink in. This puppy, 2.5 megawatts of power. And you may, at this point, I think this may have enough oomph to start a like an Airbus A380, maybe, not sure, but I'm pretty sure like two-seater dual engine jets it can start. Quad jet maybe not, but this is just at 60 liters. Imagine what they can do at 120 liters. The amount of power they can have, that's the whole point. They are trying to make this super high density systems where they may need 5 megawatts, 8 megawatts, and it does have benefits because you are removing components. The more components you remove, the simpler the maintenance becomes, the more efficient the aircraft becomes. So it's win-win all the way. Imagine you do not need multiple of this air pipe system. You will have just one backup on one engine. It's like, just in the case, let's say electrical malfunction happens and you still have to start the engine, the ground crew will pump up the air compressor and they'll like start the system, and it will only be on one engine, because again, why would you want to have extra system? So this sort of technology, once developed to the fullest extent, it would be quite amazing to have basically just one motor generator unit that's like, bro, I got this. I can provide the electricity, I can provide the starting torque, I got this. That would be awesome. Less components, longer lifespan. So that's the electrical that every company is working on right now. You will see it next 10 to 20 years. Then we come to the small thing that may have already experienced by many of you, is that in-flight Wi-Fi. Now, you have to understand, being seated inside a sealed metal tube gets boring very quickly. I was that guy, like, I will be grateful that I'm flying. I'm like, at that high speed, at that high altitude, I'm going to be out of window. I always book window seats. And I was like always trying to see at winglets and all that. Just, it got boring. It got boring after a while. I'm 30 years old. I'm sorry. It's just boring at this point. So we need Wi-Fi. So how can we achieve it? Well, this is the first option. You have air-to-ground communication. Basically, they will try to receive mobile tower signals. And again, there will be communication with service providers, like how the heck they're going to work. They work, and they may be very great for India because India has way too much mobile towers, like lot of mobile towers, idiotically large amount of mobile towers we have. Again, very large population in very small surface area, lot of service providers. We have like if air companies in India wants to do that, they can have that. If they are flying over India, almost every square inch they will have mobile towers, as in like coverage, so to say. So that is great for India, but it does come with side effect. These puppies are slow, meaning at best case scenario, you're gonna get 1 to 2 Mbps to the modem that is working in the aircraft. So each customer at best case scenario, they can do just WhatsApp texting. But again, you may stay connected, it may slowly buffer, and if not everybody is using 1 Mbps to you reliably in air, may be good enough. Then we come to the next big boy. This is a small boy, we come to the big boy. That is putting basically satellite dish on top of it. Now, LEO satellite constellation at this point in time allows far more speed. Now, be mindful, there is no LEO satellite constellation that is powerful enough. Technology is there. We have Ku band, Ka band, we got that. And because there are so few satellites, they need very big domes and they need an antenna that is facing antennas. They cannot just rely on phase shift array technology because there's not enough of them in the sky. So they need phase shift plus antennas that are facing them. So like, phase shift will do the final calculation and they have to move it this way. So what has changed? Well, SpaceX. Every other company is like, we have 100 satellites in orbit providing service right now. So you can get around 20-30 Mbps per plane, as in like divided to how many customers you have. And then that's why like whenever you see people doing in jumbo jets, their speeds are very bad because again, it's divided by so many people, is that not that good. But SpaceX is like, bro, we have 4,000 plus satellite right now. And we are targeting 10,000 and we are the only company that can actually achieve it. So you can be damn sure that each plane is getting fat pipe. And because of the coverage is so high, the wind drag penalty that they are introducing on the aircraft is much lower compared to the big bulbous thing that requires a spinning antenna inside it. So they should achieve around 100 plus Mbps for every private jet. Right now that's their market, private jets, rich people basically. So then it will go from rich people to middle class people, and at that point in time, if they have even more satellite, it would be very viable to have like 500 Mbps connection. At that point in time, you can distribute enough to enough people and still have useful connection. Like this is from Qantas. So this will be one of those things that over time it will become a reality and will not think about it. It's just like, hey, my mobile works. Of course, I'm pretty sure they will do their best to make sure that you cannot call. But it does work. Like this logo will become a common thing. That's what I want. Wi-Fi on board, common thing. Don't think too much about it. Go to a plane, works, chill. So this will be a subtle thing that will happen. Then we come to the final, elephant in the room. It's like everything I've talked about is like talking about making it a bit more better, bit more efficient, bit more user-friendly. What about the carbon footprint? Well, if any Tom, Dick and Harry tells you that we're gonna have battery or hydrogen power, ask who is their cocaine supplier, because like I need that cocaine. Because here's the deal, neither of them, of course I have wrote spelling mistake, neither the battery nor hydrogen has enough energy density to fire big jets, flat out. Flat out. Can you have a battery powered aircraft? Yes, you can buy it right now. Legally certified electric aircraft. You can just go pay money, get it right now. But here's the deal. Most of them are 2-seaters. 4-seaters are barely there, and some companies are saying they can push it to 10-2. Don't even think about 100-seater. Don't even dare to think about like 700-seater. So you have to understand, the moment you are talking about big jets, it goes away, disappears, it just disappears. Now you're like, what about hydrogen? Here's the deal. Hydrogen is something that we have experienced from 1950s. We learned it the hard way that hydrogen does not have enough megajoules. Now you're like, wait a minute, hydrogen has like 130 megajoule per kilogram. That's true. Absolutely true, factual true. Even diesel only has like 40 megajoule per kilogram. So it's like, whoa, the hydrogen is superior. Unless you add liters. At that point in time, that one has like 38 liter, another, if you are really lucky, as in like how the heck you're gonna make hydrogen into liquid, then you're gonna have like 8 megajoule per liter. Yeah, that's the point. Hydrogen does not have density. You have to liquefy it, and even then it's not dense enough. You need proof. Look at the size of fuel tank of basically space shuttle. Giant orange thing. Hydrogen. Oxygen was this small. Hydrogen was this big. So hydrogen does not have the density. So neither a battery nor hydrogen can replace our jet system. So what can we do? Well, there are many companies who are talking about like, oh, we can do this Ep205 plant and all this. Here's the deal, none of them can work on large scale, because here's everything works in small scale, everything. So do not ever be for, oh, in small scale we have already done testing. No. Can you scale this puppy up? The only technology that we have on this planet is Seaweed Biofuel, because it can scale up, meaning you need 100 square kilometer area. Now here's the deal, where will you find land that is 100 square kilometer and available? Sea. Nobody cares about it. That's why we are putting wind farms there. Nobody cares about it. That's why we are putting oil pipelines there. Nobody cares about it. That's why we're putting literally oil refineries on sea. Nobody cares about it. because the space is free, available. And every nation has like, larger sea boundaries, like India specifically. We have enough sea boundary that if you track majority of them, like I'm not even talking about touching international borders, I'm talking about just national boundary waters, we have like, we got this, fam, we got this. Enough surface area is there that we can do. And that's not all. That's the, okay, we can scale it up. What about use? That comes to another aspect. No modification to plane, meaning whatever plane you have, like you see this sort of logo, Biojet, Abu Dhabi's flight path to sustainability, and like SpiceJet is also working on it. And many companies, Virgin Galactic is also working on it. So you're like, okay, does that mean modification? No, that's the whole point. It creates fossil fuel at the end of the day. It's just fossil fuel with less time step. Basically, it's fast in temporal sense. Consequently, because you have to create it, you have to create a very large area of it. We do not have basically reserves of it. So it's just solar power with extra steps, and you get the output that goes into any jet engine as long as fuel has been made with good standard control, which it will be as long as it goes to aviation fuel. It has good tight quality control. You just put it to any jet known to man and don't think too much about it. And your CO2 output goes to neutral, meaning you are not adding CO2 to it. Basically, all the CO2 that will be emitted will be consumed by the next batch of seaweed. We have enough surface area that you can scale it up to whatever level you want. You do not have to change anything in the aviation, because again, be mindful, these things took 100-year research and development. And now we are reaching to a point where it's like, damn, it's like the amount of efficiency that these things have. We don't respect it. It's like how efficient these things have become. It's like, but this is mind-boggling. Battery, even if let's say somehow magically you can figure out densify hydrogen beyond stupid level, how the heck are you gonna make that hydrogen? That's another aspect, because like, we're just gonna make it. It's like, even if you have electric system, where the heck are you gonna get the electricity from? Because our grid right now is not 100% renewable. So think about that. And that's why I talk about this. Like, this is something that we do not have to change the infrastructure, do not have to create CO2 footprint of, discarding so many things that are going to aviation. We're like, dude, those are there, we just remove the carbon footprint of it. So seaweed biofuel is the, slowly over time, everybody will come to realization, hopefully. And then we're gonna have like, just normal plane that is just not adding CO2 to the atmosphere. So this was my presentation on basically future of aviation. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.